All right, we just got done solving rational proportions where I had a fraction on each side of the equal to sign. Now let's continue that discussion on solving rational equations, but maybe they're not proportions anymore. Maybe we have a plus and minus sign on one side and it's set equal to something else. They're called rational equations. The first thing we want to do though is still check for those domain restrictions, making sure that our denominator never equals 0. Then we might have to combine some of our fractions by adding and subtracting. And remember, anytime we add or subtract fractions, we need to make sure that we get that common denominator, right? And once our denominators are all the same, then really our denominators are no longer affecting my problem. Let me show you what I mean by that. If I have 3 over 4, and I know that it's equal to something over 4, well, if my bottoms are both 4s, then aren't my tops both 3s? If my bottoms are equal, shouldn't my tops also be equal? And so I end up getting x equals 3. Well, that happens anytime my denominators are the same. As long as my denominators are the same and they're set equal to each other, then my tops should be the same, right? My numerators should be the same. So I can kind of set aside those denominators and just work with the numerator. We can solve and then just make sure that our answer doesn't include any of those domain restrictions. Let's do a few. Look at example 2 with me. This one's asking us to solve. And if you look first at domain restrictions, my denominator here is 6, my denominator here is 8, and my denominator here is 12. I don't have any variables in my denominator, so that's good. My denominator is never going to equal 0, so there are no domain restrictions on this one. The problem is I have two fractions that I need to subtract, and before I subtract, I need to make sure that I get a common denominator. But let's actually get a common denominator between all three fractions, because once all of my fractions have a common denominator and all my denominators are equal, then I can just work with the numerators. All right, so what would be my common denominator between 6, 8, and 12? What number does 6 go into? What number does 8 go into? And what number does 12 all go into? It looks like I can change all of my denominators to a 24. I would need to multiply the first fraction, top and bottom, by 4, the second fraction by 3, and the last fraction by 2. And that way we can get all common denominators. When all my denominators are equal, remember if my denominators are equal, then that means my numerators are equal. So now I can kind of set aside my denominators and I can just look at an equation that includes just my numerators. Now my equation says 4x minus 3x equal to 2. So again, as soon as my denominators are equal, I can set them aside and just worry about the numerators. 4x minus 3x is a 1x, and I end up getting x equals 2. Remember that there was no domain restrictions, so x equals 2 should work. And you can always double check it by plugging it in and making sure that the equation is true. Let's look at b. On b, I still have three fractions. I have 1, 2, and if you want to, you can say that this 10 is a 10 over 1, right? So I have three fractions. On these fractions, I do have a couple of variables. I have a 3x in the first fraction and an x in the second fraction. So what domain restrictions do we have on this problem? It looks like on this problem, x cannot equal 0, right? So keep that in mind as we solve. Let's go ahead and get a common denominator between all three fractions. The first one has a 3x. The second one just has an x, so it looks like it needs a 3. So let's multiply the top and the bottom by 3. And the last fraction really needs both of them. It needs a 3 and an x. So let's multiply the top and the bottom by a 3 and an x. That way everybody has a denominator, a common denominator of 3x. So now your equation should look like this, right? And as soon as I know that my denominators are equal, I can go ahead and just set my numerators equal. So now I have an equation that says 2 plus 3 equals 30x, right? 2 plus 3 is 5. And if I divide both sides by 30, I end up getting 1/6. I don't want to divide by 5. I want to get the 30 away from the x, not the 5 away. So I end up getting 1/6, which is not part of my domain restrictions. Remember, the only one number that wasn't going to work is 0. So x equals 1/6 should work. All right, let's do one last one in this video. Let's look at c here. On c, it looks like we have three fractions. We have x, or x over 1, plus 6 over x equals -5. Or can I say -5 over 1? And so I notice that I have a variable in this second fraction in my denominator. And if I set that equal to 0, I know my domain restrictions are x cannot equal 0. X should be able to be anything else except for x equals 0. All right, Let's go ahead and get a common denominator. It looks like this first fraction needs an x on both the top and the bottom to keep it balanced. The middle fraction already has an x, so he's good. And the last fraction also needs an x on the top and the bottom. So that way everybody's denominator is just an x. You should end up with an x squared plus 6 equals negative 5x in your numerators. Once my denominators are equal, my numerators should also be equal. So I can go ahead and just work with my numerators now. I have an x squared plus 6 equals negative 5x. None of those are like terms, but I noticed that I have a quadratic, right? I have a trinomial with an x squared, an x, and then a constant. So it looks like I should be able to move everything to the same side and factor. So I added the 5x over, I put everything in order, and then I'm going to basic factor in order to solve it. I ended up factoring into an x plus 2 and x plus 3. I'm going to set each of those factors equal to 0, and I end up getting x equals negative 2 and x equals negative 3. And don't forget, always double check your domain restrictions and make sure that both of those answers are okay. And since they are, it looks like both of those answers should work. X can be negative 2 and negative 3, or negative 3, and it should make the equation true. All right, practice those, and then we'll look at a little bit more complicated problems here in the next example.